Hi students, MCQ number 4. Two gases are at temperatures 300K and 350K respectively. Ratio of the average kinetic energy of their molecules is to be determined. So it's a very direct question only. It is not mentioned whether it is monatomic gas or diatomic gas or triatomic, linear, non-linear like that. So I can refer to monatomic gas molecules for example. So the kinetic energy average is Ke bar. So for a monatomic gas molecule means it is 3 by 2 Kt. For diatomic molecule means it is 5 by 2 Kt including the rotational motion. So I have assumed in both the cases it is directly proportional to absolute temperature only, is it not? So the average kinetic energy for the first molecule Ke1 is proportional to T1. Its temperature T1 is 300 K. Similarly, the average kinetic energy for the second gas is proportional to its temperature T2. Okay. So this ratio only is asked. So T1 is equal to 300 K and T2 is equal to 350 K. Therefore, the ratio of kinetic energies Ke1 divided by Ke2 is equal to 300 divided by 350. So this is equal to 6 5s are and 7 5s are 35. So this is what 6 by 7. So the ratio must be equal to what 6 is to 7. Now the option B is the right answer. Okay, therefore option B is the correct answer. Now though for explanation it is taking more than a minute, but in the competitive exam and all, directly you must remember that it is directly proportional to the temperature. So this is multiples of 6, this is multiples of 7. Quickly, within few seconds, 5 seconds to 10 seconds, you can work out in mind calculation itself. Okay, you should not do it in a paper like this. Mind calculation, because the numbers are easily divisible. So time you have to manage. That is very important in any competitive examination. Okay children, I hope you must have understood this well. Fine.